This tutorial will explain how to use bus tapping on some of these inputs that we have. The reason is because we have our control logic, which is only 1 bit wide, and we're trying to control an array rather of multiplexers. So for instance, this particular multiplexer is the one that's going to be used for our increment command. So what we want to do is when this is selected, when select is 1, we want 4 zeros to take the places of any value that happens to be on the B input, and then we're going to add a 1 to the carry input of our full adder, and that's actually handled over to the right here of our circuit. That's simple stuff. We're not going to talk about that right now. So the first thing I want to do is notice that our select line here, and actually all the lines on this multiplexer are wide, and that means that they're all buses, meaning that they're in parallel. So this isn't the symbol for just one multiplexer, it's the symbol for 4 multiplexers in parallel, because if you notice we have a 3 down to 1 notation for our B input. And so when we add the ground here, we can double click this, we need to add 3 down to 1 to the name of the ground instance as well. That would allow that to connect correctly to our input. Now for the select line, I'm going to just draw this a little bit longer here. We can't give it a single bit input and expect it to work because it's 4 different multiplexers. So what we have to do is we're going to use the bus tap icon here. We're going to choose top so that we can get our bus from the top to be tapped, and we're going to add 4 taps to this select line. 1, 2, 3, and 4. Now give a little bit of space in between each of those. Now we can simply put very short signal lines off of that, and we can name each one of these. So if I were to name this particular one, this is the increment select line. I'm going to name this entire bus increment select, and then I'm going to name each one of these separately to represent each one of the bits. And what I'm doing is I'm actually clicking not on the end point of the line, but I'm clicking on the line itself, and that changes. The line is also called a net or network signal line. But what that does is it changes the just the location of where you've put the name, so that we can have these outputs here that we can use to connect to other things. So I can't just connect these 4 things together and then connect this one output to that, because what that's going to do is basically confuse the wiring in here. Xilinx is not going to be able to say, okay, well, all of these things should be connected together. It doesn't do that correctly. So what we have to do is actually add a buffer, which a buffer is very similar to an inverter, except it doesn't invert anything. So for each one of these, I am going to connect a buffer to it. Now that I have the buffer, I can add a single input to each buffer. And that should be it. So we'll do the same thing with the subtractor area here. We will extend this to 4 bits wide, name the bits as we need to, add buffers for the inputs, and then use, instead of using the increment command logic or just the input logic, we're going to use the subtract control logic, which I have here. So it would look exactly the same. Now don't forget, once you either increment or subtract, you need to make sure that you trigger the carry in bit on the full adder, and so that will actually add 1 to your number. So in this particular instance, I have the incrementer first and the subtractor second. The subtractor will do the 2's complement of whatever B happens to be. However, we've set up our control logic such that the incrementer and the subtractor cannot be triggered at the same time. So it will always only work whenever the B value is being used, and not whenever these 4 ground values are being used. So I hope that kind of clears that up for you.